Okay, so in the last class I have explained about the pulsed modulator. Okay, what do you mean by the pulse modulator, and it is what is the block diagram of the pulse modulator. Okay, and it is what is the basic principle operation of the pulsed modulator. Okay, so has been explained in the previous class. Okay, and in this class I am going to explain about the modulators and the duplexers. Okay, so in this class we are going to study it is what we mean by the radar modulator, and about the block diagram of the line modulator, and also the working principle of the line modulator, and it is what are the components to be used in order to implement the line modulator, and it is what is the introduction of the duplexer, and it is what are the types of the duplexers. Okay, and it is what is the block diagram of the branch type duplexer, and it is what is the working of the branch type it is the branch type. Okay, duplexer. Okay, all of this is it is going to be studied in this class. Okay, already you know about the basic block diagram of the radar. Okay, it is consisting of the waveform generator is to be followed by the power amplifier. Yes or no? It is in the pulsed, it is a radar block diagram. Okay, it is consisting of the waveform generator, it is to be followed by it is the power amplifier, and it is connected to the modulator there. It is pulse width modulator. So in this block you can able to see this is the modulator, which is indicated with the blue color here. Okay, so if you take the modulator in this case, so the modulator controls the radar pulse width. It is by means of the rectangular, okay, DC pulses of the required duration and amplitude. Okay, so according to the availability of the amplitude and the width of the pulse, it can able to control the amplitude of the RF signal. It is power amplifier, okay, output. So what this peak power of the transmitted RF pulse is going to depends on the amplitude or the width of the modulator pulse. So if unknowingly or unexpectedly, if the power amplifier increases its amplitude, means in this case what this modulator it will do, it is going to decreases its amplitude on decreasing its on period. In the same way, unexpected increase or unexpected decrease in the amplitude of the RF signal, it is power amplifier. So in this case what this modulator it will do, it is going to increase the on time of the width, and it is going to increases its amplitude of the RF signal. Okay, in this way, what this peak power of the transmitted RF pulse is going to depends on the amplitude and the width of the modulator pulse. And if you take the function of the modulator is to turn the transmitting tube on and off to generate the desired waveform. So in this case, its function is only to turn on or off. Its on and off is to be controlled by this modulator. Understood? So this is the definition of the modulator here. Okay, and according to the syllabus, if you take the block diagram of the line modulator, okay, it is consisting of the energy source. So it's nothing but the power supply, and it is consisting of the charging impedance. Okay, so it's nothing but any of the resistor network, and it is consisting of the energy storage element. So it's nothing but any of the capacitor or the capacitor and the inductor combination, and it is to be interconnected for the load here. Okay, this is the block diagram of the line modulator. It is implemented with the power supply, okay, charging impedance, okay, the energy storage device, and the load here. Okay, and if you take the power supply, it generally produces the high voltage output either in the alternating or the direct current. So if you take this energy source, it is going to provide the alternating current, means AC, and if you take the direct current, means it is the DC. It is going to give you the voltages in terms of the AC or in terms of the DC. And if you take the storage, element. So yeah, it's nothing but a circuit element or the network. It is used to store the energy. So that if you take this, okay, the storage element, it is used to store the energy. And if the energy is to be stored in the form of the AC, means it is going to make use of the capacitors or the inductors. And if the energy is to be get stored in the form of the DC, means it is going to make use of the batteries. Okay, it is the storage element. It is the a circuit element or the network. And if you take the charging impedance, it is used to control the charge time of the storage element and to prevent the short circuiting of the power supply. It is during the modulator pulse. Important. Okay, so if the pulse is on, means it is going to be in the charging state, and if the pulse is off, means it is under the discharging. In this way, so it is used to control the on time and the off time of the pulse here. According to this, it can able to charge or it can able to discharge here. Okay, this is the working of the charging impedance here. And if you take the modulator switch, so that you can able to see the modulator switch is present in between the charging impedance and the storage element. This is the modulator switch here, and it is used to control this on time and the off period. Okay, what this modulator switch? It is used to discharge the energy stored. It is by the storage element. It is through the transmitter oscillator. It is during the modulator pulse. During the modulator pulse, means if the pulse is on, okay, if the pulse is on, it is used to discharge the energy. If the pulse is off, it is going to charge. It is going to store the energy. Off means it is under the open switch. And if it is on, means it is under the closed switch. Understood? So that I'm going to repeat once again. If you take the block diagram of the line modulator, it is to be implemented with the energy stores, okay, charging impedance, energy storage element, and the modulator switch. And all this is to be connected for the load here. And according to this on time and the off time of the charging impedance, it can able to store the energy or it can able to discharge the energy. And according to that, it is going to give that supply to the load here. This is about the line modulator. And if you take the working of the line modulator, okay, so if you take the working principle of the line modulator, it is with the modulator switch open. If you assume this switch is open here, if the modulator switch is open, what this the transmitter is going to produce the no power at the output. It is but the storage element is going to charge and stores a large amount of the energy. It's very simple here. See here, if this switch is open, it is whatever the input, okay, energy source input, it is to be passed into the charging impedance, and afterwards it is to be passed to the energy storage element, and it will be keep on charging. The energy will be get stored here only, and at the load it is not going to flow any of the energy, but it is going to form the closed loop indicating the operation of the charging here. Okay, so that you can able to see if you take the charging path, so the flow of the current takes place as in this direction here. This is the charging path here under the open switch. With the modulator switch open, what is the transmitter produces the no power output. Output power is almost equal to zero, or it is no power output. In this case, whatever the energy source is going to supply, it is going to be get stored as in the energy storage device. Okay, and it is going to form the it is closed loop as in this way. And if the modulator switch is closed, if you assume if this switch is closed, if the modulator switch is closed, so the energy stored, it is by the storage element. The energy which is already stored, okay, it is previously under the off period, okay, is to be released or is to be discharged in the form of the high power, okay, DC modulator pulse. So if this switch is going to be closed, Okay, it is whatever the energy stored in the storage element. Okay, it is to be get discharged for the load, and it is going to form the loop as in this way here. You can able to see, so the flow of the current is going to be as in this way here. This is assumed to be as of the discharging path. This is the discharging path. And what this, so the transmitter is going to convert the DC is modular, okay, pulse is to an RF pulse, it is which is radiated into the space by the radar antenna. It is whatever the signal appearing at the load, it is itself is to be passed to the transmitter, and it is from the transmitter it is to be sent for the antenna, and it is to be radiated into the space. So what this transmitter is going to convert the DC modulator pulse, it is to the RF pulse, it is which is radiated into the space, it is by the radar antenna. And what thus the modulator switch is closed for the duration of the transmitted RF pulse, it is but open between the pulses. It's on and off, it can able to control the transmission of the RF signal. If it is on, it is under the transmission mode, and if it is off, it is under the reception mode. Understood? This is about the working of the line modulator. Understood the working here? It's very simple here. If this switch is open, means it is going to store the energy, and it is under the charging path. And if this switch is okay closed, okay, it is, so it is whatever the energy stored earlier is going to be discharged for the load, and it is under the discharging path. It's very simple. Understood? Okay. It is all about the working of the line modulator. Okay. And it is what are the components required in order to implement the modulator. So it can be implemented very easily. It is with the basic components here. If you take the power supply, it is generally produces the high voltage output, either alternating or the direct current, so that you can take any of the AC source available, either in terms of the AC or in terms of the DC. And if you take the charging impedance, it may be with the any of the resistor or an inductor, so that you can take the what any value of the resistor and the inductor, and according to those values, it can able to maintain its on time and the off time. And after that, if you take the storage element is okay, generally a capacitor or an artificial transmission line, or a it is pulse, it is forming network. So if you take the simple capacitor also, it can able to act as of the storing element, and according to the capacity of the capacitor, it can able to store its energy. Okay, and what this modulator switch is usually any of the thyristor. It is an SCR. I think you know about the SCR. Okay, it is to be used as of the modulator switch here. Okay, these are the components to be required in order to implement the radar modulators. Understood? Okay, so it's all about the modulators here. Okay, this is what this basic okay definition of the modulator. This is the block diagram of the line modulator, and what this is the working principle of the line modulator, and what the components to be required in order to implement the modulator here. Understood? Okay, and the next we'll move on to the duplexer. In this case, what do you mean by the duplexer? It's already explained in the previous classes also. So it is also acting as the switch, and it can able to give the alternate connection between the transmitter and the receiver. It is for an antenna. Okay, so that if you take the duplexer is the microwave switch. It is the what microwave switch, and it is going to give the connection for the transmission. If the signal is to be transmitted, it can able to take the signal from the transmitter, so that you can observe the what aroma. It is from the transmission, it will move into the duplexer, and it is from the duplexer it will move into the antenna, which is indicated with the red color here. Okay, or else it is also going to give the connection for the receiver under the idle state of the transmission. So it can able to take the signal from the antenna, So it is indicated with the green color here, and it will enter into the duplexer. It is from the duplexer, what this signal is to be get received by the receiver here. This is the operation of the duplexer. So if you take the duplexer is the microwave switch, it is which connects the antenna to the transmitter section for the transmission of the signal. So therefore the radar cannot, okay, is going to receive the signal is during the transmission. If the duplexer is going to give the connection for the transmitter, means it can't able to receive the signal. Okay, anyone, it is going to give the connection either for the transmitter or for the receiver, only one. It can't able to give for the both at a time. If it is going to give the if it can able to give the connection for the transmitter, means it is going to transmission of the signal. It can't able to receive the signal, it is during the transmission time. In the same way, okay, similarly it connects the antenna to the receiver section for the it is for the reception of the what signal. What the radar cannot transmit the signal, it is during the reception. Understood? Okay, and in the same way, so in this way, what this duplexer is going to isolate, it is both the transmitter and it is the receiver, okay, section. Understood? Okay, so this is about the duplexer here. Okay, definition. What this duplexer? It is the single way switch. It is going to give the connection either for the transmitter or for the receiver, only one at a time. If the operation is to be the transmission, it is to be get connected for the transmitter, and if the operation is to be reception, it is to be connected for the receiver here. Okay, and if you take the types of the duplexer, it is having the, it is number of types. It is main important types of, it is branch type duplexer. Okay, it is balanced duplexer. One more is the circulator. So according to the syllabus, it's having only the branch type duplexer. Okay, as per your syllabus. So if you take the branch type duplexer here, if you take the branch type duplexer, it is to be implemented with the two switches here. It is implemented with the two switches. It is, one is the TR switch, which is abbreviated as, it is the transmit, okay, receive. And another one is an ATR. It is indicated as NT, okay, it is transmit receive. Okay, and what this ATR, it is what is TR and ATR are to be placed at a distance of the lambda by 4. It is from the transmission line, and it is both the switches are to be separated by the distance of the lambda by 4. Understood? Artha aita enadru? See here, if you take this is the transmitter part, and if you take this as the receiver, and if you take this as the antenna. Okay, and in this you can able to see if the receiver is to be connected with the two wires here, and in between if it is to be connected with the TR switch, which is indicated as the spark gap, TR. Okay, and in the same way, so as per the receiver, it is also to be connected for the transmission line as in this way, and exactly between, so that you can able to see this is an ATR spark gap. And it is what this the what spark gap itself is acting as the switches. And if the spark is available, means it is acting as an open switch, and if the spark is not there, means it is acting as the closed switch. And in this case, ATR is acting as the spark switch for the transmitter, and what this TR is acting as the spark switch for the receiver. Okay, and all of these has to be connected exactly at the lambda by 4. Okay, it is distances, so that you can able to see if the ATR and if the TR is exactly spaced between the lambda by 4, okay, distance. And in the same way, if you take the what the transmitter and the ATR switch is also exactly, it is to be spaced of the lambda by 4 distance. In the same way, if the ATR switch and the it is the end switch is to be connected exactly at the lambda by 4, and all of these distances is to be maintained exactly the lambda by 4. Okay, so under the transmission, it is what is the operation, the what this signal is to be, it is to be moved only for the transmitter here. Okay, no, and if under the receiver it is from the antenna, so so the signal is to be get received only by the receiver. It is to be controlled by this, okay, TR and the ATR. See here, so it is during the transmission, it is both the TR and the ATR is going to look like an open circuit from the transmission line. It is therefore the antenna is going to be get connected through the transmission line. Okay, if the signal is to be get transmitted, so ATR and the TR is going to be open. So what this signal, it is from the transmitter, it is to be moved for the antenna. In the same way, it is during the reception, ATR is going to look like the short circuit across the transmission line. So it is hence the antenna will be connected, it is to the receiver, it is through the transmission line. So if the signal is to be get received, so this antenna is to be get connected for with the, it is TR is for the receiver here. Okay, so what this TR2 has the primary function of disconnecting the receiver, and the ATR tube of the disconnecting the, it is transmitter. So ATR is to be concerned for the transmission control, what this TR is to be used to control the reception. Okay, see here, it's working now. Suppose consider that it is during the transmission an arc appears across, it is both the sparks. I said that if the signal is to be transmitted, it is during the transmission, it is both the TR and ATR will be open. Okay, no? So for that purpose, under the transmission an arc appears across, it is both the sparks, okay, gaps, and it is going to cause us the TR and the ATR, it is circuits to act as the quarter wave tubes. Okay, it is closed end. So that means that, so that you can able to see the existing of the spark here. Able to see here? Okay or not? Okay, so that you can able to see if the spark is available means it is acting as an open switch. If it is acting as an open switch means the end is closed. Okay, the end is closed. If this end is also closed, and if it is also closed means it is whatever the signal transmitted by the transmitter, it is going to flow towards the antenna. It is to be represented with the dotted line here. Okay, able to see? Okay, it is during the transmission pulse an arc appears across both the TR and the ATR. If the arc appears means it is assumed to be as an open switch. If it is assumed to be as an open switch means the ends are closed. If the ends are closed means the flow of the signal is not going to take place. If the flow of the signal is, if it is not going to take place in the ATR and it is TR means it is from the transmitter, the signal is to be flowed, it is towards the antenna here. So what these circuits, okay, then it is going to reflected open circuit to the TR and the ATR circuit. It is connections to the main transmission line. It has none of the transmitted energy. It is passed through. It is these reflected opens into ATR stop or into the receiver, and it is the what? Therefore, all of the transmitted energy is to be divided into the antenna. It is to be passed into the antenna. Understood? In the same way, if you take under the receive, it is what? It is during the receiver, the amplitude of the received echo is not sufficient to cause an arc across either of the spark. So it can be assumed it is going to be open. Okay, and under this condition, the ATR circuit it is now acts as an half of your transmission line. The existing upper part is equal to lambda by 4. If you take what this lower part is equal to, it is lambda by 4, and if this has been combined, this is equal to, it is lambda by 2, half wave transmission. And okay, it is going to be terminated in a short circuit. It is going to be closed at the bottom end here, so that you can able to see it is going to be closed at the bottom end. And what this so it is, this is, it is going to be is going to be get reflected as an open circuit at the T junction. Okay, 3/4 it is wavelength away. So it is whatever the signal is going to be get received by the antenna, it is going to be flowed up to at this point, and afterwards it is going to come back and it will enter into the receiver here. It is because it is going to make the half wave which is to be closed. So it is going to come up to at this point, and it is going to close the transmitter. It is with this line, and it is whatever the signal it will enter into the receiver. What the received echoes an open circuit in the direction of the transmitter. In the direction of the transmitter is going to be the open. So however, what the receiver input impedance is to be matched to the transmission line impedance. It is okay, so that the entire received signal is going to go, it is to the receiver, it is with the minimum amount of the loss. Understood? Okay, so it's very simple here. If you understood the operation of the transmission, it's very easy to understand the operation of the reception. So under the transmission, it is going to develop the sparks at the TR and the ATR. If it is going to act, if it is going to develop the sparks, means it is going to act as an open open switch. Open switch means it is going to close the end. It is going to closes the end, and after that the flow is from the transmitter to the antenna. In the same way, under the reception, it is not going to develop the spark. If it is not going to develop the spark, means it is going to be it is what? It is closed switch. If it is going to be the closed switch, means it is going to block the ends. And so if you take this transmitter, it is going to be indicated with the half-wave transmission line, and it is going to block this line. But it is going to be an open switch. It is going to receive the signal from an antenna, and it will enter into the receiver. This is about the reception of the duplexer. And if you take the sample descriptive questions on this topic, means, so he may ask you to define it is radar modulator, and he may ask you to explain the working of the line modulator with the block diagram. And the another possible question is, he may ask you to define the duplexer and explain the working of the branch type duplexer with the transmission and the reception. Okay, so it is all about the modulators and the duplexer. And in the next class, so that we are going to study about the radar display system. Understood?